So we'll be looking at geometric progression, GP. If you check my videos, I've taught the AP, which is the arithmetic progression. So this is the second part, and we have this formula: Tn equals a r raised to the power of n minus 1, where the a stands for the first term and the r stands for the common ratio, the n stands for number of terms. So we have this question: determine the third term. Determine the third term of a geometric progression, given the first term to be 4 and the fourth term to be 108 respectively. So this is how we go. Write the formula and we put in those values. We substitute the values for the first term and the number of terms. We also substitute for the value of the fourth term, which is 108. We divide both sides and we have 27. I raised to the power 3 to give us 27, and then our ratio, common ratio, will be 3. So we move over to finding the third term. So remember, our first term is 4 and we've just been able to get the common ratio. So that's what we are solving now. We're now going to substitute for the value of the third term, which we don't know. We're going to substitute for the value of a, the first term, and we're also going to substitute for the value of the common ratio, which we just got now. Common ratio has 3, so raised to the power of 2. So we have 4 into the bracket of 9, because 3 to the power of 2 will give us 9. And when you multiply them, you have 36. Going over to another tough question, very tough. Find p if p minus 3, which is the first term, 3p plus 5, second term, and 18p minus 5, which is the third term, are 3 consecutive terms of a GP. So we proceed. First of all, our formula, which is Tn equals ar to the power of n minus 1. And now we first of all substitute for the value of the third term, which is the last there in the sequence. We pick the first term, which is p minus 3, and then our common ratio. In finding our common ratio for the geometric progression, we divide the second by the first. But in finding our common difference for the arithmetic progression, we subtract the first term from the second term. So here we're looking at the geometric and we are dividing instead of subtracting, because it is GP, not AP. Now remember, they are raised to the power of 2, so we have to split them in 2s, and p minus 3 cancels p minus 3. We have our 18p minus 5 equals over 1 equals 3p plus 5 in 2s, and then all over p minus 3. Next thing we should do, or we will have to do, is to cross multiply, whereby 18p minus 5 would multiply p minus 3 from the other end, and 1 will multiply 3p plus 5, close the bracket, 3p plus 5. Now what we'll do, we'll go ahead to expand the bracket, multiplying each term from the other bracket with the other bracket. Now 18p multiplied by p minus 3, and then minus 5 multiplied by p minus 3. And this is the results. We'll have 18p squared minus 54p minus 5p plus 15 equals, now the other parts where we have to multiply 3p plus 5 by 3p plus 5. We have 9p squared plus 15p plus 15p plus 25. Next thing we'll do is to take the like terms, collect the like terms. So all the p squares to one side, all the p's to the other side, close to the p squares, and then all the single numbers which are the constant close as well, and then everything equals 0. So plus 15 minus 25, we're collecting like terms, so their signs will change. That's the reason for the change in sign. Where you see plus, it's changing to minus because we are collecting like terms. Now after collecting the like terms, we subtract them, and then we have our 9p squared minus 89p minus 10 equals 0. If you watch this equation, it's more like a quadratic equation. So the middle number, we look for two numbers that when we multiply them, it gives us minus 90, and when we subtract them, it will give us minus 89. And those two numbers are minus 90 and plus 1. And that is what we are doing here. So splitting them, grouping them, factorization by grouping. This is what we have: 9p squared minus 90p plus p minus 10. When you factorize them, you have 9p out, p minus 10. You have 1 out, p minus 10. And then you have two brackets having the same number, pick one of them. And then you have 9p plus 1, p minus 10 equals 0. And each of them equates them to 0. We'll have from the left hand, p will be minus 1 over 9. And from the right, p will be 10. So according to the question, they said find p. So our p is having two values, minus 1 over 9 and 10. Very easy. Now you see this beautiful question, it's for